Hello. So today we'll be going through a simple implementation of a depth-first search. And the problem we've got here is this small graph, which has 5 nodes, A to E. And let's say we are trying to traverse from A to E. All right, so we'll be using these two pretty common sets or lists. You can think of them as lists. One is the frontier, which is sort of the things that we need to explore, or the nodes that we need to explore, and the explored set, which is kind of self-explanatory, and it is the nodes that we have already explored. All right, so initially you'd start with the root node inside the frontier. So the frontier is initially going to contain just the root node. Okay, so let's say we start going through the traversal now. So we are at the root node. So what we'll do is we'll just pop that off the frontier and put it into the explored set to sort of start exploring everything. Okay, so now we've put that into the explored set. We will look at its children, so B and C, and we will add its children B and C to the frontier set. So here's where the stack sort of structure comes in. What happens here is, for a stack data structure, the last item in the list will be popped off first. So in this case, there's only B and C in there. So we'll pop off we'll pop off C, and we will add it to the explored set, and we'll start exploring C. So now, after we're done with A, we'll come to C. Okay, now at C, we will look at the children of C. So obviously the only child that C has is E, node E, and therefore we will add E to the frontier. And now, remembering the concept of a stack, we will pop off the last item on the list of the frontier. So we'll pop off E and add it to the explored set. And obviously, as soon as you start exploring a particular node, you check for its condition, you check for the goal state, you check if it's the node that you're currently at is the goal. If it is, then you stop the search. And that's where this ends now. So E, as soon as you start exploring E, you check for that condition. And since E is the goal, this is where we end the algorithm, or the loop, or the iteration of it, or the traversal of the graph. So that's it. So that's the path that we had to take in order to get to E. So obviously you can notice that there's another path, let's say from A to B to E, A, B, yeah, so pretty much there's two main paths, so this one and that one. But the idea here is the concept of a stack, where you sort of take the last entry into the frontier and you start exploring that. So remember, see how B is still in the frontier? We never really explored that because we were, focusing on the last addition to the frontier. So hopefully that makes sense. I'll just swipe over to this side to show you what the algorithm looks like. So if we get rid of these markings, all right. So obviously you check for this end condition where this loop sort of checks if your frontier is empty, then the traversal is finished. Yeah. Okay. So this is popping the last item on the frontier. Initially it's just A, and then so now we have A in this current node. So current node is A. Obviously A is not the goal, so we just skip past this, and then we add it to the explored set. Let's quickly do that. And then obviously it was removed. And then we will check its children. So its children obviously are B and C. So now we'll add B and C to the frontier. And now we will loop back to the beginning, and we will pop off the last item that was added to the frontier, just C, and we will add that to the explored set. And obviously this is now C. Obviously C is not the goal. We add it to the explored set. Obviously we just did that. And we now check for the children of node C. And obviously the only child of node C is E, node E. So we'll add node E to the frontier. And so this is that step right there. And then when that is done, we loop back to the beginning of the while loop. We check, we pop off E from the frontier. This current node is now E. We check if it's the goal. It is the goal, therefore we return. Yeah. So obviously, as you can see, I should also have this in there just to sort of add it to the explored set. But you get the idea. So the path, as per the above algorithm, is A to C to E. So this was depth first search, and hopefully this video was of some help. If you have any questions, please let me know.